Welcome. I'm going to attempt to explain probability. When we see a probability expressed mathematically, it's generally PA or P of A. This is the chance of something happening. If an event is certain, we say the probability is 1 or 100%. If an event seems possible, we say the probability is 0. Most probabilities are going to fall somewhere between 0 and 1 inclusive. When most people think of probability, they're thinking of theoretical probability. So P of A is expressed as M over N, where M, the numerator, is one of a set of equally likely events, and N, the denominator, is the total number of possible outcomes, or the sample space. So if we have an event like rolling a six-sided number cube, the sample space consists of the numbers 1, 2, 3, 4, 5, or 6, all equally likely, so n equals 6. If we're looking at the probability of rolling, say, a 1 on the die, well, that represents one of all the possible outcomes, so our probability is 1 out of 6, or around 16.7%. If we're looking at the probability of rolling an even number, M is 3 because there are 3 possible even numbers, a 2, a 4, or a 6. Our sample space is still 6 because there's still 6 possible outcomes on the die. So the probability of rolling an even is 3 out of the 6, or 1/2, or 50%. The number of events you're looking for over the sample space. Moving ahead now, we're going to look at experimental probability, where our numerator uses data from observations as does our denominator. So experimental probability of an event is based on the number of times an event occurs over the number of trials in observed reality. So let's look at some frogs. There's a whole bunch of frogs, and they're different colors, and some are blue, and some are green, and some are red, periwinkle, lavender, cornflower, wisteria, or burnt umber. By actually observing and counting these frogs, I can determine the probability that any given frog is green. So I take the number of green frogs over the total number of frogs. So let's see, we have 5 green frogs and 15 total, including the green, giving us a 1 in 3 probability, or about a 33 1/3% chance. This experiment can be used to predict the amount of green frogs we'll see in future observations.